Hello there, welcome back to the new lecture. So in this lecture we are going to discuss about the chill water pipe sizing. Okay, in previous lecture already we have seen the single line chill water piping layout for chill water supplies for chill water return. Okay, so here you can see this green line is our chill water supply line. Okay, when you select the green line, automatically in layer you will get the name chill water supply. When you select the red color pipe, it is showing chill water return. Okay, so now we have to do the sizing. So here for pipe sizing, chill water pipe sizing, I am using the software. Pipe Sizer software is available. With the help of that software we have to do the pipe sizing. Okay, so before that, first we have to convert the TR in water flow rate. Okay, we have to find out the GPM for each and every equipment or FCU or AHU, because based on that only you will get the pipe size. Okay, so here you can see this is our conference, and here we have got the cooling capacity value, ton of refrigeration 3.5. Now if you want to convert this 3 point this TR value in GPM, so we have a formula for that. Okay, but first thing you have to remember, in chill water piping system we have a two system. Okay, first is closed loop piping system, and second one we have a open loop piping system. Okay, closed loop piping system means what? First try to understand. In a closed loop chill water piping system, chill water is circulated through a network of pipe to cool the building air. Okay, so from the chiller we are just using the pipe. Okay, so chill water is circulated through a network of pipe to cool the building air. So the system include a chiller unit that cools the water before it enters the piping network. Okay, so chill water absorb heat from the building air through cooling coil and then return to the chiller to cooled again. So you can see the water which we are supplying from the chiller. Okay, from the chiller, the chill water which we are supplying to the building equipment, and again from the building equipment chill water will return again to the chiller. So this complete loop, piping loop, is called as a closed loop system. So when you are doing the sizing for closed loop piping system, so you have to remember, in a closed loop chill water system the flow rate of water required to provide 1 ton of refrigeration can vary depending on factors such as the temperature difference between the supply and return water, okay, the type of chiller and the design of the system. So however, as a general guideline, 1 tr 1 ton of refrigeration typically required a flow rate of 2.5 gpm, okay, of water in a standard chill water system. So remember, 1 tr is equal to 2 point, in closed loop system 1 tr is equal to 2.5 gpm, okay, water in a standard chill water system. And when you go for open loop system, in an open loop chill water system, generally water is drawn from a nearby natural water source such as a lake or river. So the water is pumped into the system and circulated through a heat exchanger where it absorbs heat from the building air to provide cooling. After absorbing heat, the water is discharged back into the natural water source. See, open loop system means what? See, the water which we are taking from the cooling tower, see the piping system is there, na? From the cooling tower we are taking the water, then we are supplying that water to the condenser water pump. Again from the condenser water pump we are supplying water to the chiller condenser. Again from the condenser, that cold water return to the cooling tower. So this is complete open loop system. So here you have to remember, in an open loop chill water system, the flow rate required to provide 1 ton of refrigeration can also vary depending on factors such as the temperature of the water source, the efficiency of the heat exchanger, and the design of the system. So, however, a rough estimate is that 1 ton of refrigeration typically required a flow rate of around 3 gallon per minute of water in an open loop system. Okay, so here we are going to start from here, ground floor. Okay, so here we have got the ton of this is a closed loop system. Okay, the water which is coming from the chiller, then again the water which we are supplying from the machine to the chiller. So this is a closed loop system. So for closed loop system, to convert the TR, We know that 1 TR is equal to 2.5 GPM. So just convert it fast. Here you can see for this FCU, TR cooling capacity is 3.5. So 3.5 into what? 2.5. How much? 3.5 into 2.5. Here you will get 8.75 TR GPM. So I am writing here, so that in this pipe the water flowing is how much? 2.5. So here you can write down this thing. So 1 minute. GPM, how much we have got? 8.72. Or in this way you can write flow 8.72 GPM. Okay, as per GPM we have to do the sizing, that I will explain you how to do sizing and everything. Okay, so here you can use the leader line command also, like this. Use the copy command and here write down for both pipe, or you can draw, see, ellipse also, and change the layer as a text layer. So use the match property, select the source and destination. Now see, for this pipe, leader line, you can use the leader line, or otherwise simply line, straight line I am using. Okay, and then place it here. So flow rate, how much we have got for this piping routine? 8.72. Okay, so how to do the pipe size, that I will explain you. First we need to find out the flow rate value for each and every equipment. Okay, here we have got that much. Now come to here in this. So here also just copy this one, the copy command, copy it from here and write down. So for this one, flow rate, because how much capacity is showing here? 2.5. So 2.5 into 2.5, it is around 6.25. So flow rate here we have got 6.25 GPM. Okay, for this FCU. Now when you come here for this one, this pipe, so now the flow rate is different. Okay, so first I am copying this. Use the rotate command, rotate it like this, straight, and here I am writing. Use the move command. See, so for this one, how much flow rate we have to calculate? Here I am using the line command. Okay, match property, select the source and destination. Now copy this one. Now you have to add the flow rate of both FCU. So 6.25 this one plus 8.72, so it is around 14.97. means for this line flow rate is 14.97. okay, so in this way we have to calculate, increase it. Okay, now come to next here for this part. So here I am just copying this one. Use the copy command, CO enter, specify the base point and place it here. So here how much capacity is showing for corridor area? 9.5. So 9.5 into 2.5, it is around 23.75. GPM is 23.75 GPM. Okay, so you can place it here, or otherwise see what you can do, delete this one, just little bit, use the line command, and you can give the size here so that easily match property I am giving. Write down the flow value here. For this section we have got 23.7. now for this one, again I am copying this one, copy and write down here. Just mirror it in opposite direction here and write down the flow. Use the move command, place it here. So for this add 23.75 plus, and how much we have got here, 14.97. 14.97, it is around 38.72 GPM. So just write down 38.72 GPM. Okay, finally here also we have one AHU here. So okay, so see what I am doing, just copy it from here. Here write down that much and minimize the size. Use the move command, move it little bit. Okay, then here also I am drawing one line, straight line. Use the match property, MA, enter, and source object and destination. So flow is how much? See, actually the capacity of this room is how much? 10 TR. So 10 into 2.5, how much? Okay, because it is a closed loop system, so as I told you 1 TR is equal to 2.5. so for 10 TR 25 GPM. Just write down 25 GPM. Okay, and for this one here what we can do, just select this flow and copy it first, CO, enter. For each and every floor same way you have to do the sizing. Okay, see, here we are supplying with the help of AHU, we are supplying conditioner and in ballroom. So for ballroom how much capacity? 5.6. so 5.6 into 2.5, it is 14 GPM. So here I am writing 14 GPM. Okay, now for this section you will get the size same, you have to add both of them. So I am using the copy command. For this I am writing here, just place it exact. So 14 plus 25, 39 GPM. So here 39 GPM. Okay, and for this branch we have got 38. It means for main pipe. So here just select, use the copy command, place it here exact. Now our main target, we need to find out the pipe size in our main. So here how much size we have got. First on your ortho mode and just little bit move the flow. So 39 plus 39 for this branch and 38.72. 39 plus 38.72. Total is 77.72 GPM. Okay, so here we have got the flow rate for each and every section. Same way for first floor, for second floor, second to 8th floor, you have to calculate same thing. Okay, I will show you for ground floor, then you will get the idea for each and every floor. Okay, so once you will get the flow rate. Now open the software. Here see, I am opening the Pipe Sizer software. Okay, so this is our software. Here you can see McQuay Pipe Sizer. So first of all, here we are using schedule 40 steel pipe only. Okay, so here you have to write down the flow rate, see, in US GPM. So from here you have to select the size, but here two condition you have to remember. If your pipe size is coming less than or equal to 2 inch, so you have to see the fluid velocity should always be less or equal to 4 fps. And if your pipe size is more than 2 inch, so you have to see the head loss value should always be less than equal to 4 feet of water column per 100 feet of pipe length. Okay, so two conditions are there. So first of all, flow, I am going to start the pipe size for this branch. Okay, so 8.72 GPM. So here first I am just assuming 1 inch and writing 8.72. Suppose 1 inch pipe size I have selected for 8.72. So here pipe size I have selected less than 2 inch. So you have to see the fluid velocity. So see, fluid velocity is coming less than 4 fps. It means the pipe size is correct, but once we have to check little bit, just take 3 by 4 or 1 by 4 inch pipe size. Suppose for that I am writing here 8.72. see here the condition is fluid velocity is coming 1.87. so it means you can select the low size pipe. Okay, and write down the flow rate 8.72. so now, okay, you can prefer the 1 inch pipe size also. 1 by 4 inch pipe size also you can select, because the condition in that pipe also the fluid velocity less than. But here our main target is what? We have to reduce the cost also, na? So you have to go for 1 inch. Otherwise, just take le less than 1 inch size, 3 by 4 inch. For that 3 by 4 inch, you have to check the size. So 8.72. Now see, when I'm just when I have selected 3 by 4 inch pipe size for 8.722 GPM, fluid velocity is showing 5.25. It is more than 4 FPS. I have told you always, if you are selecting the pipe size less than 2 inch, so fluid velocity should always be less or equal to 4 FPS. So that is why when I'm selecting 1 inch, so it is coming right. Okay, it means, see, the fluid velocity is less than. For this section of pipe size, we have got how much? Here you can select the symbol, diameter symbol, and write down 1 inch pipe size we have got for this section. Before that, write down the size. Okay, same way come to next. For this section, 6.2 GPM it is showing. Okay, so now write down, suppose 1 inch only I have selected 6 point, first of all 3 by 4 inch. Okay, reduce the size, and 6.25 GPM. see, when I'm fluid velocity is showing 3.76. okay, so it means for this one, for this section, pipe size you can take 3 by 4 inch, because when I'm taking 3 by 4 inch pipe size, 1 inch also you can take, but better is to take the 3.4. We have to reduce the cost also, na, pipe cost. So 3 by 4, when I am selecting, fluid velocity is coming less than 3.76 fps. Okay, so here I am writing first from here diameter sign 3 by 4 inch. Okay, and here you can write down the size. Getting in this way. Now come to next, this pipe. Here we have got the flow rate 14.97. see, so open the pipe sizer. Suppose from here I am selecting 1.5 inch pipe size and writing the flow rate 9.7, 14.9. see, when I have selected 1.5 inch pipe size, so we have to see the fluid velocity. Fluid velocity is coming less than 2.36 fps. You can take this value also, but first you have to check the lower value, 1 by 4 inch. For 1 by 4 inch, when I am taking 4.97, so it is showing, yes, here, see, again the fluid velocity is less than 4 fps. It means you can select the 1 by 4 inch pipe size also, but see, for 1 inch it is possible 14.97. no, it is not possible to take 1 inch pipe size, because the fluid velocity is greater. So we have to take the 1 by 4 inch. For that, when you enter the 14.97, so it is coming velocity less than 4 fps. So here just double hit on that, write down size. Okay, symbol, you can select the diameter symbol from here. And how much? 1 by 1 1 by 4 inch pipe size we have got. Oh, here write down by 4 inch. See, the pipe size here we have written 1 by 4 inch. Now come to this section here, 23.75 na. Okay, so for 23.75 the pipe size, how much? I think 1 inch. When I'm taking 3 by 1 inch pipe size, suppose, check for 1 inch pipe size, 23.75. see, fluid velocity is more than that. It means we have to select the greater pipe size, 1 by 4 inch, and write down the flow value 23.75. Fluid velocity is around 5.09. It means just increase little bit, 1.5 inch pipe size, 23.75. Now see, the fluid velocity is less than 4 fps. Why I'm showing you the fluid velocity? Because the pipe size which we have selected is less than 2 inch or equal to 2 inch, so you have to see the fluid velocity. First condition I have shown you. So 1.5 inch pipe size is preferable. So just here you can write down the size, take the diameter symbol from here, and 1.5 inch pipe size. Okay, for this branch pipe. Now for this main branch pipe, 38.722 gpm. Okay, so for 38.72 gpm, how much pipe size? Okay, so suppose I am taking 2 inch and write down 38.72. So when you are taking the pipe size 2 inch or less than 2 inch, so you have to see the fluid velocity only. See, the fluid velocity is 3.7. It means 2 inch pipe size is preferable here. If you are taking 1 by 1.5 inch pipe size and you are just checking 38.72, see here, I think the condition is not satisfying on that time. Okay, fluid velocity is coming greater, so it means 2 inch pipe size we have to select from here. So I'm writing here, size we have got for this is 2 inch. Okay, okay. Now here also we have done 14 gpm. For 14 gpm, how much pipe size? I think 1 inch pipe is enough for 14 gpm. So I'm selecting 1 inch and here 14 gpm. Okay, fluid velocity is coming 5.2. It means we have to reduce the size or increase the size. We have to increase the size and check it. So now it is coming 3 fps. It means 1 by 4 inch pipe size. Okay, so 1 by 4 inch pipe size. Here you can just select the diameter symbol. Okay, now come to for this one, 25 gpm. So for 25 gpm pipe size, how much? Suppose 1 by 4 inch only I am selecting and write down 25. So see, the fluid velocity is coming more than 4 fp. It means now you have to increase the pipe size and write down 25 gpm. See, now it is correct. So the pipe size is 1.5 inch. Okay, so here you can write down 1.5 inch for this. Now for this main flow rate is 39. So how much pipe size? I think 2 inch we have to select. Okay, so suppose I'm selecting 2 inch, write down 39. See, the fluid velocity is coming less than, so okay, just write down 2 inch pipe size here. Okay, so here I'm writing 2 inch. Getting? Okay, so we have done this branch pipe size, this one 2 inch. Here also we have got. Now come to main pipe, 77.72 gpm. Okay, so Here now we have to select the pipe size more than suppose for 3 inch I am just checking 77.72. Now we don't need to see the fluid velocity because the pipe size we have selected greater than 2 inch. So we have to see the head loss. Head loss should always be less and equal to 4 feet of water column per 100 feet of pipe length. So here the condition is satisfying. For 3 inch condition is satisfying. See, the head loss is coming less than 4. But for that, okay, if it is coming right for 3 inch, just take 2.5 inch pipe size and check it. It is coming, condition is satisfying or not. Here see, when I am selecting 2.5 inch, then condition is not satisfying. Head loss is more than 4. So it means pipe size we have to select here 3 inch. Okay, so size of pipe is 2 inch. So here I am writing 3 inch pipe size. This is our main. So main branch pipe size which is coming in ground floor, it is 3 inch pipe size. Okay, same way you have to do for each and every row. So in this way we have to do the chilled water pipe sizing with the help of McQuay Pipe Sizer software. I hope all of you enjoy the session. See you in next one.